Hello guys, it's Krish. I hope you guys doing absolutely good. So today I'm going to talk about a little bit different topic. So I realized when I released those Ansible videos, a lot of people struggling to understand how this communication happens, which certificate to copy where, why do we need to copy this certificate, then how we can secure this, so and so forth. So I realized you guys struggle this because your lack of understanding about the SSH and those communication protocol works, right? So today in this video I'm going to explain you everything you should know about SSH, right? Not for Ansible, but everything you should know about SSH, how SSH works, what are the keys, how those key exchange works, how the authentication works, which key to go where, what are those files, how to do those a lot of things, right? So let's go. So first, what is SSH? SSH means secure shell, right? So secure shell means it includes a shell. So shell is nothing but if you log in, if you access to any server, any Linux based or Mac or anything, so you get a terminal, right? That's kind of a shell. So what does it mean? Take it this way. So you have a friend in somewhere where you don't see, right? So you can text them, right? You can ask something, hey, how are you? He will reply, I'm okay. Have you done your exams or something like that? So you can ask question, then other person will reply. It's kind of a text message. You don't talk to each other, but you exchange a text, right? So shell is something similar. So you send some message to your server through the shell, right? So you say ls, right? So server understand that and tells you what are the files you have, right? Mkdir, create a directory. Server understand that and create a directory for you. It's kind of a shell is a kind of a medium where you and your server can communicate with each other, right? So what happened if you some garbage character to your friend? He will tell you, what did you send? I don't understand this, right? It's the same. If you send something invalid command or something to the shell, so shell will tell you back, I don't understand this, right? This is a kind of you can understand that way. Shell is nothing but it's just an interface where you and your server can communicate, right? If you want to get something done from the server, you can use a shell. So SSH means secure shell, right? So before SSH come into the place, so there was a telnet and so much protocols to use this remote communication. But the problem of those protocols, you send the data in a plain text. So anyone who do the packet sniffing can read this data and can steal your data, right? So it was okay if you are using a local network within your office or something, but when internet comes, when your cloud comes, when you're trying to access the remote servers, this will be dangerous, right? So that's why SSH came into the place, right? So SSH means secure shell, right? So hope you understand. So let's see a little bit in detail about this protocol, right? So if you take SSH, it has basically three different layers, right? So first one is transport layer, right? First one is transport layer. Second one is user authentication layer, right? So third one is connection. Okay, so we don't have to go very in detail about that, but it's good you know these layers. So transport layer, basically it will do the key exchange, right? I'm going to explain in a while what this key exchange mean. Key exchange and also re-key exchange, right? So once this key exchange happen and the connection established, so this protocol is doing re-key exchange. So that means it's doing again. So after 1 GB data transfer or 1 hour of the connection, whatever come first, right? So 1 GB data transfer or 1 hour, whatever come first, it will do the re-exchange, right? Basically transport layer is responsible for do that. So user authentication layer is the one who do the identify the user, right? So basically, so this will identify the server also, right? Key exchange to identify the server, authenticate the server, right? So this will authenticate the user, right? So user authentication mainly there are 4 different ways, right? The first one is a password based, obvious, you can give the password. The second one is key exchange, public private key exchange technique. So third one is called keyboard interaction, right? So what keyboard interaction mean? If you need to supply something like an OTP, you can use the third way, right? The fourth way is GSS API. So what does that mean? If you want to take like Kerberos kind of a thing in integration into SSH, so you can use the fourth way, right? So usually third and fourth way not much popular, but the password authentication and a key exchange is the most popular, right? So today I'm going to explain detail how the key exchange works, because that is the one you struggle with the Ansible, right? Connection, it basically do three different tasks, right? So one is handle the channels basically, right? So you can, in between two servers, you can even have multiple channels, right? So it get a channel for shell, right? And also it handle direct TCP, right? So direct TCP, which mean client to server, right? And also forwarded TCP, so which mean server to client, right? Server to client. So these are the layers operate on a SSH protocol, right? Here today we are going to do little detail about this, right? So you can see here you have a server 1 and you have a server 2, right? So this server, I mean in SSH, one act as a client, right? So both this one act as a servers, one act as a client, but let's say this one is a client, right? So okay, so both SSH install, right? So now when you install SSH, you get a keys, right? Let's say this is your key, right? So server, this has SSH, so that means it has a key, right? So this is SSH installed machine, so that means that also has a key, right? Okay, something like this, all right? So now what happens is this is their public key, right? So this is their public key. I am not going to draw the private key here. So this is the public key. So you see the both keys as the same, right? So I'm going to add something else here, so you will not mix up the key, okay? So now what happens is this client want to communicate to this server, right? So when you try initiate the connection in the first layer, right, it do the authentication. The transport layer, it do the server authentication, right? So what it does is it asking give me a fingerprint, right? So what the server does is server generate a fingerprint from this public key and send it here, right? So then if user accept this, right, so user can accept this and user can store that key in a server's known host file, right? So what it tells, this server is authorized, this server is known, this can trust, right? This server can be trusted, so that's why it's stored here. So now server authentication is done. So now my client understand this server, right? It's a legitimate server. So now we need to exchange our data. Now after this, right, so this SSH connection, right, to connect here, it's trying to say, hey, I'm going to send the Krish, user Krish here, right? So when it come here, it asking from SSH configuration whether this is a password enable or certificate enable, right? So if user don't have password, if user pass some password here, so SSH will ask from the operating system, hey, Krish is trying to connect to me, he's going to give you the password as a password 123, is it okay? If server says yes, then this connection established, right? So then we can exchange the data. So take the scenario 2, its password is not enabled, right? This is a certificate based authentication. So now what happens is this client is trying to connect, right? And then this server SSH asking operating system, Krish is trying to connect. Do you have someone called Krish? Server check, okay, yeah, I have a user called Krish, okay. So now it take the certificate, the private key, inspect the private key and check associated public key, right? Associated public key inside its authorized key, okay. So I'm going to stick it here because this is not belongs to these two directories, right? So I'm going to stick also here. Okay. So this is, keep in mind, this is server SSH installations public key, right? So now this server tells, no, I don't have any public key associated with this private key. So this connection will not establish, right? So now in order to make this connection happen, what we need to do is we need to generate two key pairs here, right? Public key and a private key, right? Okay. So let's say now we generated two key pairs for this client. So this is, the red one is a private key, the yellow one is public key, right? So now this client has two keys, we generated two keys, right? So what we need to do is we need to copy this public key in this server's authorized key, in SSH directory authorized key file, right? So now again it's going to make the connection, right? So it make the connection, this server SSH asking from server, I get a request from Krish, is this an available user, right? It check with the PAM, yeah, it's available, okay. So now it check the public key associated with this private key, right? So it can find it. So now connection established, right? So now connection established, right? So to recap, let's get this quick recap, right? So when you install SSH on any machine, it has its own keys, right? So it's a SSH, it's a server instance public key. This is this instance public key, right? So now when this trying to make the connection here, right, it see the fingerprint of the server. So right, fingerprint means fingerprint of this key, right? It should available on a known host file, right? If it is not there, depend on your configuration, either it will ask to add this or it will reject, right? So now server is validated. So now when you're trying to make the connection, this is your private key, right? So you encrypt your data with the private key and trying to make the connection. Server says your user is available, whether this key must available in a authorized key file, right? So this is the way out. So if this one need to connect to here, right? If this one need to connect to here, this key's public key should available in this authorized key file, right? Authorized key file, okay? So this is how SSH works. Okay, so now let's get some edge case, right? So let's say we have something called man in the middle, right? So we have man in the middle. So man in the middle attack, right? So man in the middle attack. So now what happens is when this trying to exchange these keys, right? So instead of this server public key fingerprint, it will send this attacker's public key fingerprint into your client, right? So if you blindly say yes, okay, then you become vulnerable, right? So then he can intercept your SSH connection, right? So that's you need to make sure when you deploy the production servers very first place, right? So it's better you scan all your keys and store in this known host file, right? So this known host file, you have a user wise known host file and also you have a system wide known host file, right? So it's better install this on a system wide known host file under this this server against this server. In that case, if this attacker trying to send attacker's key here, right? So then you will not accept this connection, right? So I'll explain you practically how you can scan and store these keys, right? So you understand, right? When the attacker trying to send a different fingerprint, your SSH connection will not establish with the server because it knows exactly this is not the server, this is some different guy. Okay, here we go. So here I have set up two instances, right, and in AWS, and here let's connect to the first one. And if I check user level SSH, right, so you can see here I don't have anything, right? So I don't have any keys over there, right? So what I'm going to do is I'll demonstrate you how it just connect and how that key comes here, right? So I'm going to connect to my host, right? So I'm going to pass the key and EC2 user at this IP, right. So, you will see it will asking to save some fingerprint, right. I am going to say yes, right. So, now this is the fingerprint it stored my machine. If I exit here, if I check what is in my SSH directory now, because before it nothing was there. So, now you can see it has a non-host file, right. But here is the important thing. So, when I go to next time, it will not ask this from me, but let us go and see our server's public key, right. So, for that I am going to go etc SSH, right. So, here if you see the all available files, you can see it has ECDSA keys and RSA keys, right, and also it has a DSA keys, right. It depends on how the client requesting, it has all those 3 types of keys. So, now what I am going to do is I am going to see what is my this public key, what is inside my this public key, right. So, I am going to cat this, right. So, now I can see this is the text, right. So, this is my public key in my machine, right. So, I am going to exit this from here and I am going to see what is inside. I am going to see what is inside my local machine known host file. So, what it has known there, right. So, now you can see this is identical, right. So, this start with the 4As E2, right. So, it has 4As E2 and then you have this 230 JF and you have this thing. So, you can say it is identical, right. What it has done is it first, when I try to connect to the server, it sent me the fingerprint. I said okay, yes, accept this. So, now it stored server's public key inside my known host, right. I am going to remove my known host file, right. So, now I do not have any known host file. So, when I am trying to connect here, it will ask me fingerprint again, right. So, it is a yes, right. So, note this fingerprint. So, now what I am going to do is I am going to generate the fingerprint to my key, right. So, I am going to see what is inside my SSH directory, right. So, I am going to generate fingerprint to this key, because this is the key ECDSA key, right. So, this is the key I got, right, ECDSA. So, I am going to generate a fingerprint for this. How I can do that? What I am going to do is I am going to use SSH keygen, right, minus LF, and I am going to pass this key, right, etc SSH and then this public key, right. So, this public key, oops, should be keygen, right. So, this is the fingerprint for that key, right. So, you can see here, see. So, also this key and what it prompt us to save in my known host file is those fingerprints are identical and same, right. So, now we proven the theory when we trying to connect to remote server, right. So, remote server going to send its fingerprint generated from its public key, right. If we said yes, we trusted this, then it going to send this public key to my known host file. I told you, right, I have configured, I have set up 2 different instances, right. Now, from this instance I am going to generate a SSH key here, SSH keygen, right, and I am going to I do not want to add any passphrase, and okay, good, I have this key here, right. So, now if I check, I should have the keys in this directory, right. Right. So, you can see here it has a private key and its public key, right. So, now what I am going to do is I am going to copy this key into my other machine, right. So, what was the local IP of this machine? Okay. So, this one. So, what I am going to do is SSH copy ID, right, and I am going to copy to here, right. So, it asking fingerprint, yes. Okay. So, now it says it copied one file. Okay. So, now I am going to connect to this one, right. See what I am going to do, EC2, okay, I am going to just say SSH, right. It's like this. It didn't ask any password from me, it just allowed me to connect. Why? Because I have a private key in my machine and then I moved my public key here. So you can see here, if you cat this, so you can see here now it has a different key file, right? So it has a different key entry. See this one. So this is the original key, and you can see here it has now a different key, right? So which mean we were able to successfully generate a key and push that key, right? So now what I'm going to do is I'm going to edit that authorized key file, right? So and I'm going to remove this key, right? I'm going to remove this. Okay, I removed that and I exit, right? So now I'm trying to make this connection again, right? You know, when I'm trying to make this connection, what happens is it trying to exchange the key in between machines, right? So now you can see it cannot find any keys, right? So that's in a remote machine cannot find any valid public key to my private key. So it says, hey, give me a password, right? So now you understood, right? Okay. So one last point. So I told you this can vulnerable for hackers, right? Especially when with the man in the middle attack, right? How we can avoid that? So this is how you can do it. So I'm going to remove my non-host file, right? So now I don't have any host available. So and when I'm trying to connect here, right? Let's say for this one, it will ask to add the fingerprint. So I'm going to say no, right? So that means host validation failed. I didn't add it, right? If I'm trying to connect again, it will ask again because I didn't add, right? So no. So now what I'm going to do is I'm going to scan the key for this one, right? SSH key scan for this host, right? I'm going to tell, hey, go and scan the keys, right? And output just put into SSH and to this non-host file, right? So let's see what happened. Okay, it's in one key. It's in 3 different keys because you so that it has a 3 different protocols keys. So now I'm going to connect again. So this time it didn't ask the warning to add the fingerprint. Why? Because the fingerprint is already there. Okay, now in case if somehow its server's public key change, probably reinstall or someone delete the key and regenerate the key, for some reason if the key is changed in the server, then whatever I have in this non-host file is invalid, right? So now it will tell you your trusted fingerprint and the fingerprint coming from the servers are different. It's always best practice before you move into production, you get servers fingerprint to clients and store their non-host file, right? So now you will ask what happened if that time attacker was there. Yeah, makes sense. So what you can do is you can use the key scan and you can take their keys and store in the non-host file. And also you can go there and generate, you can log into the server, right, and generate the fingerprint for that certificate and verify this, right? So even you can generate the fingerprint for this certificate what you stored in the local, right, in my non-host file. So you can use SSH keygen minus LF and you just need to pass the key. Right, so you will see these are the fingerprints, right? So what you can do is you can go to the server and generate this fingerprint and verify whether whatever you got the fingerprints is equal or not, right? In that case you are safe. Okay, so that's all about SSH, how SSH works, what's happening behind, how the authentication works, what are the key exchange, right? So if you didn't understand, just watch this video again and you just need to memorize, you need to remember which keys go to where and what is the purpose of that key. Right, who has the public key, who has the private key, what is the purpose and which file should contain this. If you can understand that, if you can memorize this, is nothing. Okay, so subscribe to my channel if you're not subscribed yet and also click the bell icon. I'm going to upload frequently some important videos and vlogs and so many things to share. So share this video and like to my Facebook, Instagram, and stay in touch so you can ask questions and I may answer depending on the time I have. Stay safe, take care.